We're going to play a solving game. I'm going to show it to you through the graphs and kind of algebraically, just kind of throwing together what the period means and stuff like that. So here's just a couple games. So it'll be like the end of your homework. Your homework's super short. This is the last video. There's a couple of graphing ones. Dude, Desmos. Go check it out. Graph it. Learn how to use Desmos if you don't already. Go graph those things up and then go match them. We're not going to go too deep into this stuff. But the solving games? Shit. These are the games I love. So here's the question. We want to find the solutions of the equation in the interval negative 2 pi to 2 pi for tangent of x is equal to the square root of 3. And as we're first learning, it's just like, well, what the hell is that saying? Well, dude, we're used to saying this. Y is equal to tangent of x, at least for now. Start talking about y's and x's and stuff, and we write it like that. Which means that the root 3 is our y. And we're looking for the angles inside that's going to make it equal root 3. So we're like, okay, everywhere our y equals the square root of 3, well, we want to know what our x values are going to be. So if you put this in concert with that little table I gave you, so you can figure out that, hey, let me tell you one of them, pi over 3. Tangent of pi over 3 equals root 3, just from looking at the frickin' table. There's one of your solutions. But let's look at the graph. So I took their graph, added a little bit more to it. They didn't have for all the way from negative 2 pi to 2 pi. So let's talk about that. I was saying we're just going to find some solutions from here back. And these solutions are the angles. The x values are the angles. It's asking for all the freaking x values that are going to make this true. So let's put in root 3. Where's root 3? It's about here. It's about there. It's about 1.7 something. Like we'll get something here, we'll get something here, and oh no, that's outside of the. We'll get one here, and then we'll get one here. But wait, do you know the period of pi? Or shit, damn, period of tangent. It's pi. This game is super freaking easy once you know how to play it. All you have to do is find the one that makes it true. Like I already said, pi over 3. If you were to go down to here, it's pi over 3. That's the height. Tangent of pi over 3 is equal to root 3. You should have that on lock. That should be on lock. Therefore, so we're like, okay, x equals pi over 3. We found a solution. But since the period is pi, it says we can get another one. X equals pi over 3 plus pi. So there's the one pi over 3. So you can get another one by adding pi. But if you added another pi, you wouldn't be able to get it. So how about take away a pi? How about this one? X is equal to pi over 3. And now let's take away one of the pi's and go back the other direction. Oh, shoot, there's another one. X equals pi over 3. Let's take away not 1 pi, but 2 pi's. And then we're going to be able to find all 4 of our answers. I mean, there's all 4 of our answers. We just need to clean it up. So we got our first one is x is equal to pi over 3. There's our first. This one, we gotta go 3 pi over 3, so we get 4 pi over 3. Actually, I'm gonna write a 1 there. I'm just gonna write a list. Let's just list it. I don't know why I did that. X is equal to 4 pi over 3. And now we can't keep going that way, so we handle this one and this one. Now we go to here. Oh, 3 pi over 3. So you got x is equal to 1 pi over 3 minus 3 pi over 3. That's negative 2 pi's over 3. Sorry, my stuff is starting to get corrupted. I've been making this shit for quite a while now. So we get x is equal to negative 2 pi over 3. And then our last one, this is going to be x is equal to pi over 3 minus 6 pi over 3. So x is equal to negative 5 pi over 3. And this is because tangent has a period of pi. Unlike sine and cosine, that requires a little bit more work. Secant and cosecant? Shit, that's going to make life a lot rougher. You're going to have some problems with it, or some exercises in your homework with cosecants and secants, and this requires just a bit more thought. So let's do an example of one. Let's look at let's do secant of x is equal to the square root of 2. And we want to find everything, all of our answers for all of our x values in between negative 2 pi and 2 pi. Now, I don't know about you. I sure as hell don't want to solve for secant. I don't waste any brain space for this. I get this, and you go to heck. You get out of here with that nonsense. I don't want to do this. I would much rather take this and be like, look, flip it over. Cosine of x is equal to 1 over the square root of 2. Wait a second. What if you rationalize this? What do you get? Cosine of x is equal to the root 2 over 2. Uh-oh. Uh-oh. What about that table? Remember that table? Oh, shit. You remember that table? Let's put it in with cosine. See those thetas? Oh, dude, thetas, angles, they're x's. They're just x's. 0 gave you 1, and pi over 6 gave you root 3 over 2, and then pi over 4 gave you, oh, there it is, root 2 over 2. There's our guy, so that must have been that pi over 4 is a solution. Sweet! That's awesome. So we found one of them, but we got to go get 4. That would challenge you to actually kind of move away from the period thing. So let's just graph cosine of x real quick. Parent function, not getting too weird. Hey look, there we go. There's our y-axis. We're going through 1. Got our negative 1 down here. Here's our x-axis. So the 2 pi is here, and to negative 2 pi is here. So root 2 over 2 is about here. So like, how many solutions should we get? 1 and 2, 3 and 4. Oh, so we should get 4 from negative 2 pi to 2 pi. We're going to get 4. But it's not going to work where you can just add pi to it, because the period is not pi. The period is not pi. Sine, cosine, cosecant, and secant, its period is 2 pi's, not 1 pi. So you can't play that game of just adding pi like we did in the last one. But what we could know is cosine's an even function. Look at this. Pi over 4. Look how it's even. It's all symmetric. Negative pi over 4 will work too. Oh shit. X equals negative pi over 4. And then if we could just go find that thing in the ASTC. Remember that between the fourth quadrant? Remember the fourth quadrant where cosine's positive? Right in between 3 pi over 2 and 2 pi. Hey, you know anything that has a reference angle of pi over 4? In that fourth quadrant? Do you think maybe you could figure it out? That maybe we have what would that be? Maybe we're like, I don't know the angles. I don't have them memorized yet. So you're like pi over 4. 2 pi over 4. 3 pi over 4. 4 pi over 4. Right? And it just goes well. Now keep going, keep going, keep going. 5 pi over 4. 6 pi over 4. That's 3 pi over 2. 7 pi over 4. Oh shit, that's a pi over 4. It's got the same freaking reference. I go, we're going backwards. That must be the one. 7 pi over 4. Yes, nailed it. But look at this. Cosine's what we call an even function. It's symmetric about the y-axis. If you come back here, this is also negative 7 pi over 4. Sine and tangent work the opposite of it. They don't have the same thing. They're odd functions. This is an even function. So I use a little trickery to go through it. You might have to use a combination of your unit circle. You might want to use your graphs. You might want to use a graphing utility and just go look at it. But this is a game that we're going to have to get really good with later. Not necessarily right now. We're just getting, this is our first little like jump into it. But it becomes a big part of our life very soon here. So yeah, do your best. Do your best. You just got a couple homework problems with it. And I'll see you on the other side after your first test. So good luck, study hard. Hey, just do your best. Don't psych yourself out. It's just a stupid test. Huh? And then we'll come back and we'll start messing with inverses next. See y'all.